Welcome back. Today we're going to go ahead and continue on with angle relationships again. And in fact, we're going to take it a step further and also solve equations based off of those relationships. First, our content objective is students will be able to solve equations involving angle relationships. Language objective is students will be able to state verbally the relationship between the angles. Why am I learning this? Well, it's important for real-life problems like making mirrors into a submarine for periscopes. So first, background knowledge. Let's recall some of the stuff that we went over in our previous lesson. We talked about vertical angles, complementary angles, supplementary angles, corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles, triangle angle sum theorem, the quadrilateral angle, so many. So now we're going to actually be applying all of those characteristics into figuring out some missing angles based off of expressions and things like that. So quickly, just to remind you about parallel angles, we know that corresponding angles are congruent. So for example, angle 1 and 5 correspond to each other, so they're congruent. We can even prove it by a translation. Angle 2 and 6 are congruent because those are corresponding angles. 3 and 7 are congruent since they are corresponding angles, and angle 4 and 8 are congruent since they are corresponding angles. Now we also talked about alternate interior angles. It's basically the angles on the inside of the parallel lines, and the alternate ones, one on the left, one on the right. 3 and 6 are alternate interior, and you're going to find that alternate interior angles are congruent. And we can prove it by a rotation to prove that they are indeed congruent there. And the reason why rotation is evidence that they are congruent because rotation preserves shape and size. So that means the shape is exactly the same size. That means corresponding angles are congruent. Also, 4 and 5 are also alternate interior angles. So there's another pair there. And then we have alternate exterior angles. So alternate exterior is on the outside of the parallel line. So 1 and 8 are alternate exterior. And again, I can prove it to you by a rotation there. Also, 2 and 7 are alternate exterior angles. Now, one thing that I do want to mention is some students might say, oh, wait, well, couldn't you consider 7 and 8 to be alternate exterior because they're on the outside, one's on the left, one's on the right? The answer is no, because 7 and 8 are considered to be supplementary angles, so please don't confuse them. Okay, same side, basically same side interior angles as the angles on the inside, and they're on the same side. They're both either on the left, both on the right, and they add up to be 180 degrees. That's a good thing to remember. We did a problem like this. Remember, my first tip to you was to identify the vertical angles. Those are really quick and easy to identify. And the next thing you want to look for are supplementary angles. From there, you might want to start looking for corresponding angles to figure out some of the other ones. So that's my method of solving what the missing angles are. Again, first go with vertical angles. Second, look at supplementary angles. And last, look for corresponding angles. And then if I need more, I can venture into alternate interior, alternate exterior, things like that. But the main ones that I use are vertical angles, supplementary angles, and corresponding. But again, there's multiple ways of solving and for missing angles, so feel free to use whatever you deem fit. Okay, so here it says, how do we really know that these lines are parallel? Well, it says, suppose you are given two lines J and K in a picture below. You have been asked to determine whether the two lines are parallel. You start by drawing a transversal L through the two lines shown below. Devise a strategy to determine whether the two lines are parallel using what you know about the properties of rigid motion. Next, use your strategy to determine whether lines D and E are parallel. Just saying they do not look parallel is not a justification. And often you might see in your homework problem, they'll say not drawn to scale and things like that. So please be careful. You just can't say, oh, look, they look parallel, so I know that they are. Okay, that's not going to be enough. So here, a transversal is drawn here. Now, we're asked to go ahead and defend that whether or not these lines are parallel using some sort of rigid motion. So let's go ahead and do that. First, like I said, most of you guys would probably say, oh, well, it looks parallel, but how can we prove it? Well, in order to prove that lines are parallel, we can use different rigid motions like translations, rotations, or reflections. Now, the ones that are probably going to help us out is translation or rotation. So here, I can say this angle is congruent to this angle, okay, due to translation. And then with the rotation, I can see that this angle here is congruent to this angle by rotation. Okay, so again, I repeat this process. These angles are congruent because of translation, and then these two angles are congruent because of rotation or translation, one or the other, depending on from which one are you comparing the other one to. So I know that these are indeed parallel, but why? Because we can take both angles by a translation or a rotation. And because that these are rigid motion, they are the same size, same shape, meaning they're congruent, which means all corresponding angles are congruent. So because of those reasons, since they are since they are congruent, corresponding angles are congruent, I know that the lines are parallel. Now let's take a look at this one. Let's do the same thing. Let's look at an angle. If I translated it down, are they congruent? No. In fact, right away, I know these lines are not parallel because corresponding angles need to be congruent, and they're not. But for further proof, just to show you, this angle here corresponds to this angle. They're not the same either. So real quick, that is not the same as this one, nor was it the same as this one, which it should have been since vertical angles are congruent. Okay, so here they are not congruent, therefore again they're not parallel. But further proof, this angle here, okay, is congruent to this one, but not the previous one, so they are not parallel. Since we when we take both angles, translate and rotate, we see that the angles do not line up, and because of those reasons, those lines are not parallel. Because if they did line up, that means the angles are exactly the same, meaning they're congruent, and because they did not, they are not congruent. It says here, determine whether the following sets of lines are parallel or not to provide justification for your response. So is P parallel to Q? Why or why not? Well, first of all, I see that these angles, the relationship that they share are the fact that they are on the outside, so they're exterior. And they are on alternate sides. One's on the left, one's on the right. So this is alternate, sorry, not alternate. Yeah, it is alternate exterior angles. And what do we know about alternate exterior angles? Well, I know that when lines are parallel, these alternate exterior angles are supposed to be congruent. Well, guess what? They are congruent, which means because they are, I know the lines are parallel. Now, real quick, let me track back. When we know that lines are parallel, when this happens, we know a couple things. We know that alternate exterior angles are congruent. So now I'm just working my way backwards. If lines are parallel, I know that alternate exterior angles are congruent. So now, working backwards, if I know that alternate exterior angles are congruent, I also know that lines are parallel. So, now looking at number 3, it says, is M parallel to N? Why or why not? Well, let's see. Here, there's no relationship between this and this that I can characterize it by. So what I could do is figure out this angle right here. So I'm just going to call it X for right now, because I know that X and 91 are supplementary. So if I put angle X plus 91 is 180, I'm going to solve for X by subtracting 91 from both sides and find that X equals, let's see, 180 minus 91. We can borrow, and we're going to be left with, 89. So here I know this angle is going to be 89 degrees. Now here, these two angles do have a relationship. They're alternate interior angles. They're on the inside of the parallel lines. One's on the left, one's on the right. Guess what? Here, if the lines were parallel, alternate exterior angles should be congruent. Guess what? They are not. And for those reasons, I would say they are not parallel, because you would expect in this case, alternate exterior angles to be the same. So I'm going to say no because alternate interior angles are not congruent. But you'll notice I did have a different answer below. Now some students might look at it this differently. Some students might have said, okay, well, if I know this is 86, I know that these two angles here are supplementary. So if you call this y and solve and say, okay, y plus 86 is 180, that makes y 89 degrees. So if this is 89 degrees, corresponding angles should be congruent. These correspond to one another. Guess what? They didn't. So again, you still come to the same conclusion. They are not parallel. So please understand that one justification might be slightly different than another. Doesn't mean one is right or better than another. It just means there are multiple ways to get to the same conclusion. So now what I'd like you to do is go ahead and pause the video and try number 4 and 5 on your own. Are the lines parallel? Why or why not? Go. Okay, so let's see how we did. Hopefully you said that number 4, P and Q are indeed parallel, because we'll notice that alternate interior angles are congruent. For number 5, hopefully you said that they are not congruent, because if you solved, you would find that corresponding angles are not congruent. You'll notice that this angle here corresponds to this angle. They are not the same. So for those reasons, they are not parallel. Because if they were, again, corresponding angles should be congruent. So now here it says solve for x, explain your reasoning. Okay, it says given L is parallel to M, so these are parallel. Okay, since they're parallel, I'm going to go ahead and compare some of these things. Well, because they're parallel, I expect corresponding angles to be congruent, which means this should be congruent to this angle. Well, it doesn't say what this angle is. However, I do know this symbol here means that this is a right angle. So that means this angle, 20x plus 10, is congruent or equal to this angle here, which is a right angle, which is 90 degrees. So to solve for x, what I'm going to have to do is subtract 10 from both sides, leaving me with 20x equals 80. This means 20 times x, so the inverse would be to divide by 20 to both sides. And I'm left with x equals 4. You can even see the zeros canceling out there. 8 divided by 2 is 4. So to answer the question, I'm going to say x equals 4. How did I know this? Because corresponding angles are congruent. And there is your answer. Okay, so now let's take a look at number 7. It says given M is parallel to N. I'm just going to go ahead and annotate that. M is parallel to N. How am I supposed to figure this out? Well, let's look at the relationship of these two angles. Well, 75 and 11x minus 2, the relationship that they have is that they're both alternate interior angles. What do we know about alternate interior angles? We know that they are congruent, which means these are equal to one another. So I'm going to set it up as 75 equals 11x minus 2. So in order to solve for x, I need to get rid of this constant first and add 2 to both sides. That's going to leave me with 77 equals 11x. Real quick, 11x means 11 times x, so in order to solve for x, I'm going to do the inverse by dividing both sides by 11. 77 divided by 11 is 7. Here, the 11s cancel each other out, leaving me with 7 equals x. So here, I can say 7 equals x. How do I know? Because alternate interior angles are congruent. So there's my answer. Now what I'd like you to do is go ahead and pause the video and try number 8 on your own. Okay, so let's see how we did. Guess what? We know that vertical angles are congruent, so here 15x minus 30 is congruent to this. And again, this symbol means that it's a 90-degree angle, it's a right angle. So if you set it up, you should have gotten 15x minus 30 equals 90 degrees. In order to solve for x, subtract 30 from both sides first, leaving you with 15x equals 120. divide both sides by 15, and you'd be left with x equals 8. How would you know that this is true? Well, because we know that vertical angles are congruent. There we go. Okay, next, I want you to go ahead and pause the video once again and try number 9 on your own. Let's see how we did. Well, it says here for number 9, given m is parallel to n. Let's solve for x. This one is once again interior angles. They're on the inside of the parallel lines, but however, these are not alternate interiors. These are same side interior angles. And if you recall, same side interior angles are supplementary. They do add up to 180. So I'm going to set it up as 72 plus 12x equals 180, or this, generally we do put the variables first, and that's why it was written this way. I'm going to get rid of the constant by subtracting 72 from both sides, leaving me with 12x equals 108. Now 12x means 12 times x, so simply divide both sides by 12 to do the inverse, and we're left with x equals 9. And I know this to be true. Why? Because same side interior angles are supplementary, meaning they do add up to 180 degrees. Okay, so now let's take a look at this. Solving for missing angles. So we do have some missing angles here. We have W, X, and Y. But I do notice there's another angle here that's not labeled, but we still need to figure it out. So I'm just going to go ahead and also give it another variable. They're not asking for this, but whenever you don't know something in math, you tend to use a variable. So I'm going to call it A. You can call it whatever you want, but I called it A. Well, I do know that this symbol means that it's a right angle, which means it adds up to 90 degrees. So I'm going to go ahead and state that, hey, A plus 64 is supposed to equal 90 degrees. So to solve for A, I'm going to subtract 64 from both sides, which leaves me with A equals 26. So now I know that this is 26 degrees. I'm just going to go ahead and replace A with 26 degrees. Now from here, I can go ahead and extend it to this other triangle. I know, based on the triangle sum theorem, that these angles, the interior angles of a triangle, add up to 180 degrees. So I'm going to go ahead and set up my equation and say these angles are going to add up 180 degrees. So we're going to say W plus 121 degrees plus 26 is supposed to equal 180 degrees. So first we're going to combine like terms. So we're going to combine 21 and 26, leaving me with W plus 147 equals 180 degrees. To solve for W, I'm going to subtract 147 from both sides, which leaves me with W equals 33 degrees. So now we know the angle of W is 33 degrees. So now what I can do is, let's clean this up again. I'm just going to do that. So this is 33 and this is 26. Okay, now in order to figure out some more, I'm going to look at different triangles. Now I'm going to look at this triangle right here, this big one. Okay, I know this angle here is 90, okay, and I know this angle is 33, plus this unknown angle, which is y. Since it's a triangle, they should add up to 180 degrees, so I'm going to say they equal 180 degrees here. So in order to solve for y, I'm going to combine like terms. 90 and 33 gives me 123 degrees plus y equals 180 degrees. Solve for y, I'm going to subtract 123 from both sides, and I'm left with y equals 57 degrees. Okay, so now that we have that, we only have one last angle, which is x. Now there's two ways that you can look at this. You can go ahead and look at this triangle on the inside. Let me highlight that real quick. You can look at this triangle here and understand, okay, well, all of these angles need to add up to 180 degrees because of the triangle sum theorem. Or you can say, I think, which is a little bit easier, you can say, oh, look, these lines are supplementary. And I know that 121 plus x should equal 180 degrees, and then solve from there. So there's different ways of solving it. You're still going to get the same exact answer. It's whatever you see first and whatever you deem to be easier for you to solve. So in this case, I would get that x equals 59 degrees. So to answer the question, I know angle W is 33 degrees. I know that angle X is 59 degrees. And last but not least, angle Y is 57 degrees. Now, they didn't name this. I named this one myself. That's why I didn't bother including it in my answer. So go ahead and pause the video and try 11 on your own. Okay, so let's see how well we did. Hopefully the first thing you recognize is that these angles here are supplementary. So you set it up as 64 plus E should equal 180 degrees. So in order to solve for E, subtract 64 from both sides, and that should leave you with E is 116 degrees. So I know this is 116 degrees. Now that I know that, well, I can focus my attention on this triangle here, and remember that all interior angles of a triangle has a sum of 180 degrees. So I can set it up as 21 plus 116 plus F equals 180. Here we can just go ahead and combine like terms, leaving us with 137 plus F equals 180. Then to solve for F, simply subtract 137 from both sides, leaving us with F equals 43 degrees. So to answer the question, angle E is 116 degrees and angle F is 43 degrees. Go ahead and pause the video and try number 12 by yourself as well. So for number 12, I can start going back to my checklist. Are there any vertical angles? Yes, and that tells me some. Because of this, I know that angle R is also 95 degrees. Just as easily, I know that these lines are supplementary, which means angle T plus 95 should equal 180 degrees. For that reason, in order to solve for T, I'm going to subtract 95 from both sides and be left with T equals, let's see, I believe it's about 85 degrees. So here T is 85 degrees. Guess what? So is S. Now from here, I'm going to go ahead and move on to Q. Why did I move on to P? Because there's not enough information to go and figure out what the angle for P is. So I'm going to go ahead and focus my attention here. I can see that these lines are supplementary. They add up to 180 degrees. So I'm going to set it up as Q plus 154 is equal to 180 degrees. To solve for Q, simply subtract 154 from both sides, and we're left with Q equals 26 degrees. Well, now that we know Q, we have a way of figuring out what P is. I can go ahead and focus my attention on this triangle right here. And again, I know that the sum of all interior angles in a triangle add up to 180 degrees. So I can set it up as P plus, I know this is now 95, plus 26 equals 180. So we're going to just combine like terms and get left with P plus 121 equals 180 degrees. So we're going to subtract 121 from both sides and be left with P equals 59 degrees. So here I know angle P is 59 degrees, angle Q is 26 degrees, and angle R is 95 degrees, angle T is 85 degrees, but so is angle S. I want to apologize real quick. I know this is very sloppy, but hopefully you can at least understand what numbers I'm writing down. Okay, moving on. So now what I'm going to do is go ahead and go over number 13 with you guys so that you can try the next one on your own. So again, going through my checklist, the first thing I like to always check is for vertical angles. Now right away I see 67 here, so the one across from it is going to be 3, so I know that angle 3 is also 67. Now something you want to be very careful about is you might see this angle right here that reads 45. Please do not assume that it's congruent to angle 2. You have to be very careful, okay? First of all, you have to recognize that this is not the same. So now what I'm going to do is go ahead and use some knowledge about supplementary angles. All of these angles form a straight line, so that means 45 plus the measure of angle 1 plus 67 should equal 180 degrees. So I just added all of these three angles. So here I'm going to combine like terms and be left with the measure of angle 1 plus 112 equals 180 degrees. Subtract 112 from both sides. Whoops, that's not 112. Let's try that again, 112. And we would be left with the measure of angle 1 equals 68 degrees. So here, I'm going to go ahead and put that angle 1 is 68 degrees. Okay, now from here, hopefully you recognize that this angle is the angle that matches up with angle 2. They are vertical angles, which means angle 2 is composed of a 45-68 angle. So to figure that, I'm going to say 68 plus 67 equals the measurement of angle 2. So if you add those together, you're going to get 135 degrees for the measure of angle 2. So let's write that in, 135. Guess what? Now that I know these, I know that what these angles are because these correspond to them. 5 corresponds to 67 degrees. 135 corresponds to angle 6. Then from there, if I wanted to, I can continue corresponding or just say, hey, look, these angles are vertical angles. So this is 67. These are vertical angles. So this is 135 degrees. Please understand there's multiple ways of getting to the same answer. The order in which you went through things might be totally different from mine, but you should end up with the same exact. So now what I'd like you to do is go ahead and pause the video and try 14 on your own. Okay, so let's see how well we did. Hopefully you went and found the angle of the measurement of angle 5 by recognizing that these two angles are supplementary. By solving it, you should have gotten that angle 5 is 70, but guess what? Angle 5 is congruent to angle M. Sorry, not angle M, angle 8, okay? Which is also congruent to angle 1, because 1 corresponds to 8. And then, of course, 1 is congruent to angle 3, because angle 1 and angle 3 are vertical angles. So notice how these create chain reactions. If you know 1, you might be able to figure out a couple more. So here, angle 5, angle 8, 1, and 3 are all 70 degrees. So this is 70 degrees. This is 70 degrees. This is 70 degrees. And this is also 70 degrees. Now from there, I can easily go ahead and look for the measurement of angle 2. Well, I know that these angles are supplementary. So I know they have to add up to 180. Right? Angle 2 and angle 3. Or I can just simply say, look, angle 2 corresponds to 110. So what is the measurement of angle 2? 110 as well. So this is not a missing angle, so I don't want to bother there. But now I can go ahead and take a look at some more angles here. I know that this angle here is vertical angles to 110 degrees, which means these two angles together should add up to 110. So I'm going to go ahead and say 62 plus the measure of angle 4 is 110. So we're just going to subtract 62 from both sides to solve for the measure of angle 4, which is going to give me 48 degrees. Now from there, I'm able to get a little bit more information. I can go ahead and look at angle 6. Now angle 6, I can see, are also in alternate interior angles. I'm going to try to change the color. Here, right here, alternate interior angles with angle 4. So I know that the measure of angle 6 also needs to be 48 degrees. And then easily, these are supplementary, so this has to be how much? Well, it has to be 48 plus the measure of angle 7 is 180 degrees, so subtract 48 from both sides. And I'm left with the measure of angle 4 is 132 degrees. I know that was extremely messy, I apologize, but hopefully you're able to follow. So now, for the very last one, I want you to go ahead, pause the video, and try this one by yourself. First, I'd like to, as always, check for vertical angles because it makes it really easy for me. So here, I know that angle 5 is also need to be 40 degrees since 5 and 40 are vertical angles. I know here that angle 30 should also be 80 degrees since those are vertical angles. Now, I would go next to supplementary angles. Since this is 40 degrees, I know angle 6 should be 140 degrees because 40 plus 140 is 180. So again, since I know this is 140, I know this is also 140 from vertical angles, or you could redo the supplementary angles. Now, real quick before I move on to this one, I know that all of these angles corresponds to these as well. So guess what? Angle 1 is 40 because 1 corresponds to 5. 3 corresponds to 7, so this is 140. Now, to keep things simple, you can just say, okay, vertical angles are congruent. This is 40. Vertical angles are congruent. This is 140. Okay, so now moving my attention here, we already did vertical angles are congruent. Now we can move on to supplementary angles. Well, they need to add up to 180 degrees, so this has got to be 100, making this one 100 as well, because vertical angles are congruent. Now, how am I supposed to figure out this? Well, because of these parallel lines, I know that corresponding angles are congruent. So 28 corresponds to 25, so this has got to be 100, making this one 100 as well. 24 corresponds to this 80 degrees, so this is 80 degrees, and so is angle 27. Now from here, how am I supposed to figure out all of these? Well, I can go ahead and compare them to the fact that this forms a triangle. So all of these angles should add up to 180 degrees. So I'm going to go ahead and say 40 plus 80 plus the measure of angle 18 is 180 degrees. This adds up to 120 plus the measurement of angle 18 equals 180 degrees. Subtract 120 from both sides, and I'm left with the measure of angle 18 equals, let's see, 60 degrees. So if this is 60 degrees, guess what? So is this. And these are supplementary angles, so this is 120 degrees, making this one 120 degrees. Now at this point I can stop. Why? Because all of these angles corresponds with these angles. So I can say 18 corresponds to 10, so this is 60 degrees. And then just go on from there. And you're going to find this to be true with all of these. So you're going to say, okay, well 8 corresponds to 16, so this is 120. They're vertical angles. And you're going to repeat this process with the others. They're going to be exactly the same. And again, you can just justify it by vertical angles are, corresponding angles are congruent, or possibly vertical angles once you get one of them, and go on from there. So again, please don't let the look of it intimidate you. Just once you get the ball rolling, it starts to reveal even more answers based on what you know about alternate interior angles, alternate exterior angles, corresponding angles, vertical angles, supplementary angles, all different relationships that we've learned so far about these angles. So thank you so much for tuning in. That's going to be the end of our lesson. Until next time, bye.